Over the years, tyre technology has gone through a lot of different phases, and originally we had tubeless, and tubeless were the fastest tyres, or were perceived to be the fastest tyres, and then clinchers got better and better, and now we're moving into tubeless and hookless. But where is tyre technology goes, because these new technologies don't seem to be the perfect tyre or the perfect technology which relates to puncture proof and also speed. So what are the hurdles that manufacturers need to get over, and where are they going in the future? So what are the hurdles that manufacturers need to get over? And when we look at a tyre, we look at the hysteresis in the tyre. And the hysteresis in the tyre is the amount of energy that the tyre takes away. And this varies on the material and obviously on the thickness. If you've got some thick material and you're trying to squeeze it in and out like this, it takes more energy. Whilst if you have something that's like a t-shirt material and it's very fine, you go like this and it doesn't take anywhere near as much energy. That's why cotton tyres with very high thread per inch rates generally are better than tyres that are much thicker and rubberized and slower. But the trade-off to that is you get better puncture protection compared to less hysteresis used. So that is one of the challenges. Now, with the older technology, the tuber technology, it was just a sewn up tube. So basically it's just got a donut on the rim, and the rim doesn't actually have to take any force of the pressure in the tyre. It's just stuck on. So all the rim has to do is basically hold you up on the bike. But when you go to the technologies where they're clinchers, tubeless or hookless, then the rim is actually taking some of the force or the pressure, or is part of the casing of that tyre when it's inflated. Now, the good old clincher tyre, which I believe is the best tyre for general use, and even up to training and all that sort of stuff. Also, although I don't use them, I use tubeless, and I just use tubeless because I prefer to use them. I like using them, and I'm probably just more familiar with them, so that's why I like to use tubeless. But clinchers, I do believe, for everyday use is really the best tyre. It's got a tube in it. The tube can be taken out. It can very easily be patched. You can carry another tube and be put in very easily, and the tyre can be taken off. And even if it's cut, you can put like bits of money and stuff like that in to get you home. And generally, those sorts of things for repairs, you can stop at really any bike shop, and they will have pretty much. Most shops will have the equipment to be able to fix your bike and get your bike going. So there's a lot of advantages to the good old clincher tyre. So that's what we've got. The clincher's been around for a long time, and tubulars have been around for a long time, but tubulars are kind of phasing out. And manufacturers want us to move towards tubeless technology and also hookless technology. So what are these technologies offering us? And the biggest problem with tubeless tyres originally was they're pretty thick, and the rims weren't ready for them, and unfortunately still there is no general standard for the tubeless tyres, which is a bit of a shame. Different manufacturers do make them slightly different, and unfortunately to have a consistent fit across rims and across tyres, the standard for the bead and the recess needs to be really uniform, and that has been a problem in the market. Mavic really tried to fix that, but obviously that type of tyre was expensive. It didn't really take off. So that was something that a manufacturer has tried to cure, but generally we need more consistency across the manufacturers. But the tubeless really has started to take off, and the way they make them, they've been able to make the walls thinner, and they'll be able to make them more compliant and with less hysteresis, so we can use these tyres, and they're getting as good as, or approaching as good as, clinchers, but offering some higher level of puncture protection. Now, the problem with this technology is that unlike a clincher or a tubular, there is some assistance to holding the tyre on the rim. With a tubular, it's a sewn up donut, so as long as the stitching holds and the material doesn't break, it's an enclosed system. With a clincher system, we have a tube in there, and the tube actually applies a force to the hooks, which actually hold them in place. So they actually have to push the tube in to pop off the rim and expand the tyre or flex the tyre. So when we go to a tubeless type tyre and we remove the tube, then we have no membrane that's putting pressure on that hook. So what we need to rely on is the tyre's ability not to expand. The tyre cannot get bigger or flex or expand. And to do this, you need to put threads in the sidewall that are unstretchable. And this is also the same that you need with a hookless rim. So if you can kind of imagine it, if the tyre can get bigger like this, the hook can fall out and come off. So you need to have ribs in that tyre or some material that goes all the way around that cannot allow that tyre to stretch or get bigger. And that is how they make them, and that's why they're harder to get on the rims, and that's why now rims are coming with a groove in the center, so you can push that tyre into that groove and then you can get it on the other side, because you're getting a little bit more movement, not stretch, but a little bit more of that tyre is coming more towards the other side of the rim, so you can get it on and seat it on the rim. So of course this creates challenges in the manufacturing, and it limits the ability of the tyre to work at higher pressures. And this is why at the moment hookless rims, which are completely reliant, there is no hook at all, they're completely reliant on these threads in the tyre, that they are limiting the pressure to 72 psi. And that is one of the challenges tyre manufacturers are making. And the reason why they want to go to this type of technology is because to make the hooks on a clincher rim are quite difficult, and the moulding and the way they do it and to get the carbon compressed and get it consistent is quite difficult. Whilst with a hookless rim, they can use a flat metal plate and they can compress it and get good compression and good compaction at the hook where the tyre has its interface with the rim. So these technologies are here today, and they have a few challenges. And one of the challenges is the hysteresis, and the other challenges is that they're not always fully reliable. Even they say they give you extra puncture protection, the sealant and everything that's in them doesn't always work. It doesn't always fix the hole, and and even if you have a plug, the plug may not work. It just, and especially if the tyre comes unseated on the rim, you can have all sorts of problems. They still can give you a failure out on the street where you can't ride the bike, and then you have to carry a tube just like you do with a clincher, and that's where I see there's very little benefit. If you're carrying a tube, if you have to carry a tube, the tubeless doesn't really offer you much extra advantage with that tyre, because if you buy a open tubular, which is basically a clincher, and you use latex tubes, you're going to get a very, very fast rolling, very fast tyre with a low rolling resistance. And if you go to a tubeless, okay, you haven't got a tube in there, but you've got sealant floating around, and they have to make the tyre a little bit stronger or put these threads in to prevent it from coming off the rim. And then we've got hookless, which are completely reliant on these threads going around the rim. So what manufacturers have started to do, they've started to use inserts to offer a full puncture protection. So even if your sealant doesn't work, then there's this insert that they put in a tyre, like they've kind of used in the mountain bike area, but the technology is a little bit different, because if you use something that's very similar to a mountain bike, you actually increase the hysteresis, and then the rolling resistance gets greater. So that's one of the problems. But Victoria have come up with a novel system where it uses the air pressure in the tyre to shrink that insert. So basically it sits on the metal or carbon rim and is not in contact with the tyre, and because it's not in contact with the tyre, it doesn't add to the hysteresis of the tyre, and this gives it a significant advantage. So you've got the puncture protection and you've also got the low rolling resistance. But the big negative with this, it's more expensive. You have to buy the kit, and you have to use special tools to get the tyre on the rim when you put the insert in, and the initial mounting is quite difficult to get that into the tyre. So this is one of the disadvantages with using any type of insert, and I've seen I've seen professional bike mechanics spending, half an hour and they still haven't got one wheel assembled in a bike shop. So these sorts of inserts are quite difficult, but we might find as future goes on that these technologies, and if they adapt or design the whole rim tyre insert combination to work together, we might find that they become easier to mount and they can offer a higher level of puncture resistance whilst they're also offering a very light, pliable sidewall tyre that's very fast. Well, in conclusion, my thoughts on a lot of these new technologies like hookless and tubeless, I still think that they haven't got that technology perfected yet. And the reason why that is it's a number of reasons. The reasons is because the standard of fitment across the manufacturers, because they're made by different companies, is not consistent. And you can have one person use one rim and one sort of brand of tyre and it fits on really well and they have no problems. And then you can have someone who buys a different brand of tyre, different brand of rim, and he's pulling his hair out trying to get it mounted. And also, if you come to remount them, when they're old, or put them on other tyres, you can have problems as well. And if also you're working with all the sealant, which sealant can be pretty messy, and especially if you get quite a significant puncture out in the field, you can get sealant all over your bike and get sealant everywhere and all over your hand, and it can be just a pain, right? And I think that with tubeless, my view on it is you need to be able to not have to take a tube. If they can get the technology that good that it basically fixes almost every puncture, then that technology to me is when it's really come of age, but then also gives you the performance of a normal clincher tyre. But the challenges are still there, and I still believe that the older technologies are still better, and I still believe that the tubular tyre, from me using it, is really one of the best systems because you're not relying on the rim to hold the tyre on the rim. It's a closed system. You can still put sealants in it, so you can still have some extra level of protection, or you can put the sealant out in the field if you get a puncture, and you can also carry a spare tyre. But what we want to get to with a tubeless or a hookless is not to carry any spare anything. So we can ride our bike, and this insert or the sealant in the tyre will allow us to keep riding even if we have a puncture to get home, so then we can fix it at home or fix it at the bike shop. And I don't think those technologies are here yet. And also with the hookless, that is so new, it needs so much more work, and I don't think that they've got the tyres and the rims and everything anywhere near where they need to be. And I also think those type of systems also will need to run an insert. So where we want to be in the future is a tubeless style of tyre that's potentially hookless, and it has an insert and runs sealant, and we really don't have to take anything with us. Maybe a plug, max. And those things then give us full confidence that we can ride, and we can get the low rolling resistance, and we can get that high level of puncture protection. Because you really got to ask yourself, why then do you want to move from a standard tube clincher tyre to any of these new technologies? Because it really is still a clincher tyre without a tube, and if it's not giving you any significant advantage, why go for all that hassle of mounting and put sealant in and all this and the extra expense that's related to running those type of systems, and hassle for what value are you getting back? Well, anyway, leave your comments down below, because I know people have had very good experiences with tubeless and even hookless, and other people, I've even seen YouTubers who are very experienced cyclists, and they've had significant problems with tubeless. So I would love to hear your thoughts. And also, I'm not talking about gravel bikes and mountain bikes that have big tyres on them, because it run at quite lower pressures, like 30 or 40 psi. I'm talking about road race tyres. So don't come back and go, oh, I've had tubeless and I've been riding my mountain bike and I've never had a problem, because the way that sealants performs at lower pressures is significantly different than if it's at higher pressures. Well, anyway, guys, that's where I'm going to leave it. And remember to smash that like button. And if you're not subscribed and you're one of those people who's a ninja watcher, remember to subscribe down below. That's where I'm going to leave it, guys. Thanks for watching. I'll see you next vid.